Hi children, how are you? Are you fine? Today I am going to teach about isosters and isoelectronic species. Okay, let us discuss about that. Before going to explain this one, what I explained before in the previous class. So have you completed isotones, isobars, isodiapers and also atomic numbers 1 to 20 elements, mass numbers also? Children, practice it or not? Everyone should practice. Today I am going to teach about isosters. So let us discuss about the isosters. Students, let us discuss about the concept 1, atomic structure, isosters and also isoelectronic species. So this is already I explained in previous class. Lithium, this is mass number, this is atomic number. Actually I have given notes that you practice, no need to follow this one. Okay, what I have given notes that you practice. Before going to explain the isosters, so let me explain once isotopes. Already before class I explained this one, but here this was given by Soddy, scientist name. And also isotopes of the element, same element having same atomic number, different mass numbers. This is also I explained. Isotopes of hydrogen also I explained. Let's go to the next part. Then this is the isotopes of carbon. See, any element that is a spherical shape only. So electrons are revolving around the nucleus and nucleus which is present at the center. This is the carbon only. So here electrons are revolving, here protons and neutrons are present here. Okay, so examples of isotopes. See, center protons and neutrons are present. Protons and neutrons are present at the center, that is called as nucleus. Here carbon, if you observe this one, first isotope carbon, atomic number C612, protons 6, electrons 6, protons 6, electrons 6, neutrons 6, 12 minus 6, so 6 neutrons, okay na? So what I am telling, isotopes of carbon, see, protons, neutrons present at the center of the nucleus, so this is about the first isotope. This is the first isotope, C6, first isotope. And second isotope, this is C614, protons 6, electrons 6 and 14 minus 6 here, 8 neutrons. This is how much? 8 neutrons, this is 6 protons, 6 electrons, 6 neutrons. But I am talking about the nucleus. These two are present in the nucleus. Those two are present in the nucleus. Understand? So 6 protons, 8 neutrons, these are present at the center, what I kept in box. Then 6 electrons which are revolving around the nucleus. The 6 electrons are revolving around the nucleus. So this is the second isotope of the carbon. This is the first isotope of the carbon. Understanding, children? So this is the isotopes of carbon, structural representation of the isotopes of the carbon. So this is the isotopes of hydrogen. This is 1H1, 1 proton, 1 electron, 0 neutrons and 1 protons. These two are present at the center of the atom. Next, here 1H2, this is 1H2, deuterium. This is the isotope of hydrogen. And here 1 proton, electrons 1, neutrons 2 minus 1. So neutrons 2 minus 1, how much? 1 neutron. So these two are present at the center. Next, 1H3, 1H3, protons 1, electrons 1, 3 minus 1. How much? 2 neutrons, 1 proton. These two are present at the center of the nucleus. These two are present at the center of the nucleus. Structural representation of the isotopes of hydrogen and isotopes of the carbon. This is about the isotopes, atoms of the same elements which are having same atomic number but different mass numbers, having physical properties different, chemical properties same. So this is already explained. So this is also explained yesterday's class. So applications of isotopes. So uranium, so here uranium 92-238, atomic number 92, atomic mass 238, which is used in fuel. Uranium is used in fuel in the nuclear reactors. This is the isotope of uranium. Uranium 92-238. It is one of the isotope of uranium. 92-238. This is it is used in the fuel in your nuclear reactors. And cobalt, very very important. Cobalt 2760. This is used in the treatment of cancer. This is the isotope of the cobalt. Isotope of cobalt. It is used in treatment of cancer. Treatment of cancer. This is the isotopes of cobalt and isotope of uranium. These are the applications or uses. First one is what? Uranium. Second one is what? Cobalt. Cobalt is used in treatment of cancer and uranium isotope is used in the fuel in your nuclear reactors. So this is about the isotopes and applications of isotopes. Just I am reminding you yesterday's class, but extra some information I am giving from the book. Here use applications. Iodine is used in the treatment of goiter. Treatment of goiter. This is the isotope of iodine. And next, sodium isotope is used in differentiating the cancerous tissues from the normal tissues. Cancerous tissues ni మనం డిఫరెన్షియేట్ చేయడానికి కోసం ఈ యొక్క సోడియం అనే ఐసోటోప్ని, ఆ ఐసోటోప్ సోడియం 1124 అనే ఐసోటోప్ని యూజ్ చేస్తాం. నెక్స్ట్, దిస్ కార్బన్ 614 ఈజ్ యూజ్డ్ ఇన్ ద డేటింగ్ ఆఫ్ ఫాసిల్ శాంపిల్స్. ఫాసిల్ శాంపిల్స్ డేటింగ్ చేయడం కోసం ఈ యొక్క ఐసోటోప్ని యూజ్ చేస్తాం. Isobars, this was given by Aston. This was given by Aston scientist. And next, atoms of different elements have different atomic number but mass number is same. This is known as isobar. This is already explained. So example, calcium, this is also explained before. Next, examples also explained. Next, isodiaphers. Isodiaphers, same atoms of different elements have same isotopic number. This is important. Isotopic number A minus 2Z. Yesterday I told you N minus P. A minus 2Z which is coming from N minus P. Neutrons minus protons. So this is also I explained before. This is about the isotones. Isotones, or you may call it as isoneutronic species or isotonic. All are same only, same number of neutrons. Example, 1H3 2He4. This is also I explained before. Just I am reminding you, A minus Z, number of neutrons are same. This is only I am going to explain. This is isosters. Isosters. So what is isosters? Isosters, number of atoms are same and the number of electrons also same. Not only the atoms and also same number of electrons. That is called as isosters. Understanding, children? So what I am telling here, isosters, that molecules are having same atomic number and also same number of electrons. Let us see that. This is the example CO2 carbon dioxide N2O. So here number of atoms 1 carbon 1 and oxygens 2, 1 plus 2 3. This is for this one, and this atoms 2 plus 1, nitrogens 2 and oxygens 1, so 2 plus 1 3. So these two are equal, number of atoms are equal. And also electrons, carbon atomic number 6, electrons also 6, so 6 I have written. Next oxygens, atomic number of oxygen is 8, number of electrons also 8, but how many oxygens are there? 2 oxygens are there, 2 into 8, 2 into 8, you should write 2 into 8, not 8 into 2, 2 into 8, so total 22 number of electrons. In this case, this is about this one only. Next, N2O, atomic number of nitrogen 7, how many nitrogens? 2, 2 into 7, 14, plus oxygen, atomic number 8. So 2 into 7, you should write 2 into 7 plus 8, atomic number of oxygen is 8. So that is about the number of electrons in the N2O. So how many electrons are present in the N2O? 2 into 7, 14 plus 8, 22 electrons. In the case of carbon dioxide also same only. So this is about the number of atoms are same, number of electrons is same. So in which molecules atomic number of atoms are same and number of electrons is same, so that is called as what, children? Isosters. Let's go to the isoelectronic species. Some more examples are there in this case. CaO, this is CaO, you should write and separately write KF. This is the second example. Calcium oxide and KF. So calcium atomic number 20, oxygen atomic number 8. How much now? 20 plus 8, 28. Divide that. So this is 28. In this case, potassium fluoride, potassium atomic number 19. 19 plus fluorine 9. So total how much? 19 plus 9, 28. In the case of calcium oxide, in the case of KF, both are number of electrons are same and atoms also same. CaO, number of atoms 2, calcium 1, oxygen 1. KF, number of atoms, potassium 1, fluoride 1. So total 2. So this is about 2, number of atoms is same and number of electrons also same. So that is called as isosters. Next example, OF2, oxygen difluoride, and this is HClO you can write as HOCl, you can write it as hypochlorous acid, name is hypochlorous acid, HClO, you can write it as HOCl also. So here what I am telling, HClO, both are same only, hypochlorous acid, name hypochlorous acid. This is oxygen difluoride. So how many atoms are there in this? 3 atoms are there. Here in this also 1, 2, 3 atoms are there. Let us see the first electrons, atomic number 8, oxygen atomic number 8 and fluorine atomic number 9. But how many are there? 2 into 9. So total 8 plus 18. 8 plus 18, how much? 26. So here 26 electrons are there, 26 electrons. In this case, hydrogen 1, oxygen 8, chlorine 17, Total how much? 17 plus 1, 18. 18 plus 8, 26. So here 26 electrons, here also 26 electrons. So number of electrons is same, number of atoms also same. Understanding, children? Everyone, are you understanding? So number of atoms is same, number of electrons is same. In these three examples, first one is CO2 and N2O, second one is CaO and KF, third one is OF2 and HOCl. These are the three examples to explain the isosters. Let's discuss about the isoelectronic species. Isoelectronic species. This is about the isosters. Isoelectronic species. Isoelectronic species. What is isoelectronic species? Number of electrons is same. Iso means same. Electronic means electrons. Same number of electrons. The species, it may be species. That means it may be ions. It may be atoms. It may be ions. It may be atoms. So those are having same number of electrons. Same number of electrons. See, let us see that Cl minus. Cl minus is a Cl chloride. Ar is the argon. Cl minus and argon. Cl minus, chlorine atomic number 17. Now minus means you should add electron. If it is minus, you should add the electron. If it is plus, you should remove the electron. If it is minus, you should add the electron. If it is plus, you should remove the electron. Understanding? So Cl minus, here atomic number 17, you should add one electron, then you will get the 18 plus 17 plus 1, so total 18 electrons. So 18 electrons. But in the case of argon, total 18 electrons. Atomic number 18, so 18 electrons. So same number of electrons. Either species, that is ion and atom. Ion, species, atom. Both are same number of electrons. This is a pair of electronic species. So next one, H2O and NH3. Not only ions, not only the atoms, and also molecules. Molecules are having same number of electrons. So let us see that H2O, atomic H2O, I am taking H2O and also NH3. So NH3 is nothing but what, ammonia. This is ammonia. Ammonia. So this is water. Atomic number hydrogen 1. But how many hydrogens are there? 2 hydrogens are there. So 2 hydrogens means how many? Atomic number hydrogen is 1. 2 hydrogens are there. Total how much? 2 hydrogens. 2 plus oxygen atomic number 8. So if it is 8, should write 8 protons. Sorry, 8 electrons. 8. So total how many? 10 electrons in this case. Water molecule contains 10 electrons. Here ammonia atomic number, nitrogen atomic number, in ammonia nitrogen atomic number 7, hydrogen 1, but 3 hydrogens are there, plus 3. So this implies 7 plus 3, 10 electrons. So this is about the isoelectronic species, same number of electrons. The species which are having same number of electrons. It may be ions, it may be atom, it may be molecules. So BF3, boron trifluoride, SO2, sulfur dioxide. BF3 means what? Boron trifluoride, and SO2 means sulfur dioxide. See, boron atomic number 5, so you should write 5. F, fluorine atomic number is 9. So how many fluorines are there? 3 fluorines. 3 into 9. So you should write first 3. Don't write 9 first. 3 into 9. So 5 plus 3 into 9. 5 plus 27. Total how many electrons? 32 electrons. SO2, sulfur dioxide. Sulfur atomic number 16. Oxygen atomic number 8. But how many oxygens are there? 2. 2 into 8. So how much? Sulfur 16. 16 plus 16. So total 32. So 32 electrons are present in this case. So in this case 32 electrons. In this case 32 electrons. In this case also 32 electrons. This is about the atomic number of electrons, total. This is called as isoelectronic species. So today I explained about isosters, isoelectronic species. Let us discuss about some worksheet questions. Before going to explain the worksheet questions, so let me explain this part based on the concept. See, the mass number of neutrons is double, the mass of electrons is half. Then find the atomic mass of carbon in this case, and what is the percentage. See, this is the isotope of carbon, C612. Here electrons 6 and protons 6. Next neutrons how much? 6, because 12 minus 6. Number of neutrons 12 minus 6, 6 neutrons. Then here this is what? Mass 12. So now if the mass of neutrons is double, mass of neutrons double means how much? See, 6. Actually this is protons 6, electrons 6, neutrons how much now? Neutrons generally 12 minus 6. Yes or no? Now this is 6 neutrons, 6 neutrons. Now this 6 neutrons, what happened? Double means how much, 12. Now mass of electron is how much? Half. Half means how much, this is 12. Here how much? Here you should add half. So total how much? 18. Okay, 18. So now write the species. This is, now here see once, neutrons 12, protons 6 only. Now C6, protons 6 means atomic number 6 only. But here how much it is? C614. See, before what is given? In this case the mass of neutrons is double, then the mass of electrons is half. Then what is the answer? 12 plus 6, 18. So carbon, protons 6. This is not changed. So 6 here. Then according to this data, given data, so this becomes 18. Because this given data, neutrons are double and mass of electron is half. So C618. Right, let's go to the next part. So this is C618. Now he is asking the note, mass of electron is negligible. It is not considered in the atomic mass. Now step 2, percentage, increment. Final mass is how much? 18. Because final mass is 18. Okay, because here, so final mass is how much? So right, final mass is 18. So initial mass is how much, 12. Initial mass is 12. 18 minus 12 by initial mass. In order to want the increment, that means how much percentage? So after, see this question, see here it is given this one. So C6 12, C6 12, okay, C6 12, protons 6, electrons 6, neutrons 6. But here according to this data, total is 18 only. Okay, 18 only. So but I want what now? I want, so here percentage of increment. So 18 minus, this is the final mass by minus initial mass by initial mass. So how much you will get? 6 by 12 into 100. Here also percentage na 100. So 1 by 2, then 2 becomes here. So this becomes 50%. So answer is this. Understanding the concept completed. I am going to teach about worksheet questions. ప్రతి ఒక్కరు కూడా కాన్సెప్ట్ని క్లియర్గా చదవండి. కాన్సెప్ట్ చదవకుండా వర్క్షీట్ క్వశ్చన్స్ చేయొద్దు. టేక్ టైమ్ అండ్ ప్రాక్టీస్. ప్రతి ఒక్కరు కూడా టైం తీసుకొని కాన్సెప్ట్ ఎవరైతే నంబర్ ఆఫ్ టైమ్స్ ప్రాక్టీస్ చేస్తారో, టైం ఎక్కువ తీసుకోండి, ప్రాబ్లం లేదు, మీరు టైం ఎక్కువ తీసుకోండి, కాన్సెప్ట్ మాత్రం చదవకుండా వర్క్షీట్ క్వశ్చన్స్ ఎవరు చేయొద్దు. నేనే మొత్తం చెప్పేస్తాను వర్క్షీట్ క్వశ్చన్స్ అన్నీ కూడా, మీరు ఫాలో అవటమే. ఓకే చిల్డ్రన్, అర్థమైందా? రైట్.